Hey Betty Sue, are you busy right now?
Hi. Just inventory of some of these laboratory chemicals we have. These are different acids and bases that we have been testing.
Okay, we think we know what's wrong with that dog. We ran some tests and we've determined what chemical is most likely causing his illness. So I was coming to you to see what different treatment options we have that we could give Mr. Cletus.
I'm going to need chemical formulas before we can finish talking about treatment options.
Okay, is the name okay, or do you actually need the formula for it?
I believe we already have the names available. I'm going to need the chemical formulas.
Okay, we will determine the formulas and we'll get back to you as soon as we have that.
Thank you very much.
Hey Vet Tech, I see you're looking at our different treatment options. Before Betty Sue is able to give us our different options that we can actually use, we need to determine the formulas of the chemical that is causing Mr. Cletus' dog to be sick, not the name of it. So I'm going to show you how to determine the formula based on the name of a chemical. Naming acids requires a few simple steps. The first one is to look at the ending of the name. If your acid name ends in "ic," like chloric acid for example, you're looking for an anion that ends in "ate" or "ate." If your acid ends in "us," like phosphorus or chlorous acid for example, you're looking for an anion that ends in "ite." Both of these would be found on your polyatomic chart, not your standard periodic table. However, if you have an acid that says hydro-blank-ic acid, for example hydrochloric acid or hydroionic acid, that's something that you would look for on the periodic table. Once you found your anion, you're going to write the formula for the anion as well as the charge. Remember that your charge is the small numbers found up in the top corner, and anions always have negative charges. After that, you would add hydrogen in front, since all acids start with hydrogen. The charge for hydrogen will always be +1 because it's a group 1 element. And finally, you want to balance the charges. By balancing the charges, we mean that you have an equal number of positive and negative charges. Let's look at a few examples to illustrate these steps. The first example we're going to look at is chloric acid. When I look at the name of this acid, I see that it ends in "ic." That tells me that I am looking for an anion that ends in "ate." Since chlor is the front, I know it's going to be chlorate. So I want to find on my polyatomic chart where chlorate is located. Chlorate is located right here, and here's my formula. So when I go to write my anion formula for chlorate, I'm going to write ClO3, and I'm also going to include the -1 charge. Step 3 says to add hydrogen in front. Hydrogen has a +1. At this point, the charges are already balanced. Hydrogen has a +1, chlorine has a -1, so I don't need to do anything except combine them together. My final answer for chloric acid would be HClO3 as my formula. For my next example, I'm going to look at sulfurous acid. In this case, my ending is OUS, so that ending tells me that I'm looking for something that ends in ITE. So I'm looking for something like sulfurite or whatever I can find that's closest to that. In this case, the closest thing to sulfurite is actually going to be sulfite down here at the bottom. And my formula for sulfate down here at the bottom is SO3 -2. So if I write my formula, SO3 -2 is my charge. I still add hydrogen, which always has a +1 out front. However, in this case, my charges are not balanced. So in order to make them balanced for the positive and negative to be equal, I end up needing an additional hydrogen, which is going to make my final formula, since I have 2 hydrogens and 1 sulfite, H2SO3. Notice that once you write the formulas together, the charges have canceled and you no longer write your exponent charges. You just write the subscripts at the bottom. The final example we'll look at is hydrophosphoric acid. For this one, if you notice, I have hydro out in front as well as the "ic" at the end. So this tells me that I'm looking for something that ends in "ide," and I'm actually going to look on my periodic table. So I want to find phosphide, or the closest thing to it on the periodic table, which just ends up being simple P. The charge for P is going to be a -3 because it's in group 15, which has a -3 charge. Again, I'm going to add H out in front. H always has a +1. In this case, to get hydrogen to be balanced, I need to have 3 hydrogens total so that my 3 positives add up to my 3 negatives. And at the end, my final formula would be H3P. Now we need to talk about how you would write the formula for bases. Bases are actually easier than acids because you don't have to deal with any polyatomic ions except hydroxide. The first thing you do is to write the cation formula. In this case, it's usually just a single element and charge. Add hydroxide, which is OH with a -1 to the back, and then balance the charges. The only tricky part here is that sometimes you'll need parentheses, and we'll do a few examples so that you can see. The first example we're going to look at is going to be barium hydroxide. When I talk about the cation, I'm talking about the element at the beginning that has a positive charge. The symbol for barium is Ba. Barium has a charge of +2 when you look on your periodic table. So then I need to add hydroxide at the back, which has a charge of -1. In order to get these charges balanced, I know I'm going to need 2 hydroxides. However, when I go to write my final answer, 1 barium and 2 hydroxides, if I were to put the 2 right here, it doesn't actually say 2 hydroxides. It says 2 hydrogens. So in order to make sure that I have 2 hydroxides as a whole, I'm going to put hydroxide inside parentheses. So BaOH2 with OH being inside parentheses. To look at another example, we're going to look at aluminum hydroxide. In this case, aluminum has a charge of +3. Its symbol is Al. OH still has a -1. So many of you have figured out by now that in order to get these balanced, I'm going to need 3 hydroxides to balance out the 1 aluminum. So my formula for aluminum hydroxide is AlOH3. Again, since I needed more than 1 hydroxide, it has to go inside parentheses. For the final example, we're going to look at rubidium hydroxide. In this case, the formula for rubidium is Rb. Rubidium is in group 1, so it has a +1 charge. Hydroxide still has the same -1 it's always had. At this point, it's already balanced. I need 1 rubidium to balance out 1 hydroxide, 1 positive, 1 negative. So when I write my formula, I do not need to include parentheses because I only have 1 hydroxide. So the only time you need parentheses is when you need more than 1 hydroxide to balance out the positive charges given by the cation.